The second special right triangle that we considered in class was the half square, or the 45, 45, 90 degree triangle. So let's consider a square and cut it exactly in half. If I was to do that, this angle that was 90 degrees would be cut in half, so I would have two 45-degree angles. And the same would be true down here. This would be a 45-degree angle. So this is why we have this square that's 45, 45, 90. Now, because it was a square, all of these sides are equal in length. And for example, if I was to say that this side had a length of 1, this would have a length of 1. And by the Pythagorean theorem, the hypotenuse would have a length of the square root of 2. And if I were to extract that and say, let's say that the side wasn't necessarily 1, but it was any variable x, then the other leg would be also x units long, and the hypotenuse would be x times the square root of 2. So let's consider a couple examples of this special right triangle. But before we do that, let's just point out, summarize that if we know the length of one of the legs, the other leg would be equal. So the legs are always going to be equal in length. If I know the length of a leg and I need to figure out the length of the hypotenuse, of course I'm just going to multiply times the square root of 3. And if I'm going to go the other direction, if I'm going to start with the hypotenuse and I need to figure out what the missing leg is, then we would be dividing by the square root of 3. So these observations are enough for us to figure out the two sides of a special, the 45, 45, 90, if we're given one of the sides. So let's consider a couple examples now. So if one of our legs was 12 units long, 12 inches long, for example, that could be our units. The other one would be 12 inches. And the hypotenuse would be 12 times the square root of 2. Oh, that's pretty straightforward, and it's going to be the case for all of those. If I told you that the length of the hypotenuse was 3 times the square root of 2, to go the other direction, of course, we would be dividing by root 2, and 3 root 2 divided by root 2 would just give me the 3. And then, of course, the more slightly difficult example, probably the most challenging case, and it's not really that challenging, is if I told you the hypotenuse was 15. In order to get to the short leg, we would have to take that 15 and again divide by the square root of 2. We wouldn't leave our answer like this because we've been talking about rationalizing the denominator. So I would just simply multiply both the numerator and denominator times the square root of 2. Of course, we're just multiplying by 1, so we're not changing the value, we're just changing the form of our answer. That would give me, in my numerator, 15 times root 2, so 15 times the square root of 2. And then my denominator would be root 2 times root 2, which is the number 4. And I would leave it like this. There's no common factor with 15 and 4, so I just leave it as 15 root 2 over 4. And again, if you were to compare these two numbers, 15 root 2 over 4, with 15 divided by the square root of 2, they would absolutely be equal to each other. So that's our second special right triangle, the 45, 45, 90, or half square.